Hey guys, today we're doing some section 2.3, finding trig function values. You can notice that we have two sections here, using a calculator and without a calculator. So I do want to save this section for class tomorrow, just because I want to be able to help you figure out where the buttons are on your calculator and what you might be typing incorrectly if you're not getting the right answer. So skip this section. We're going to talk about that in class tomorrow. Bring your calculators in class tomorrow. You should have it anyways, but it's probably a good idea to have a graphing calculator. I know some of you have still been using scientific, but now that you have proven to me that you know how to convert degrees, minutes, seconds to decimal degrees, etc., now you can use those buttons in the calculator to do that. So there's a degrees button in the calculator, there's a minutes button, there's also a seconds button. You'll be wanting to use that so you don't have to convert everything to use your scientific calculator. So keep that in mind. Let's go on to the without a calculator part, and this is a little bit review and a little bit of an expansion of what we've talked about in class already. So the first thing we're going to do is I want to talk briefly to remind you on what happens as the angle or the theta increases, what happens to the sine, what happens to the function, etc. So if you remember, what we talked about in class when we did these types of problems is that we actually drew two angles, one of them 40 degrees, and let's say this is our 40. And then what happens if I increase the degree just a little bit to 50 degrees? So here's what our picture looks like, and remember that when we're talking about sine, that's the ratio of y over r. And the r is always 1 when we're doing these unit circle types of problems. So really what we're looking at, since this is a sine question, is what's happening to the y value. So at 40 degrees, look at how tall my triangle is, versus at 50 degrees, look how tall my triangle is. So you can see that the y value went from something small to something bigger. So that means that the sine of the 50 degrees is in fact bigger than the sine of the 40 degrees. This is true. And that's again because sine is using the y value, and when I went from 40 degrees to 50 degrees, the y value of my triangle got bigger. Let's try another one. So here we are with cosine. We're going to draw a similar picture, and I'm just looking at quadrant 1 because the degrees are 46 and 23 here. So for 46 degrees, that looks something like so. And if I change it to 23 degrees, then that looks a little bit different. Remember that the r value is the same because it's just the radius of the circle as we're moving around. But remember that cosine is x over r, and the r is always 1, so we're really looking at the x values here. So what's happening to the x value here versus the x value got bigger when I made the angle smaller? So that one is like the reverse. As the theta increases, the cosine decreases. So this is actually false. The reason for that is the x value is in fact bigger for the smaller angle. Okay? So let's try a couple more because these can get a little bit tricky. Sine and cosine. Oh crap. Okay, so remember that there's a way to turn these into having the same function. You can have them both in terms of sine or both in terms of cosine. You should still get the same answer regardless of which way you think about using the cofunctions for, but I'm going to change this. Instead of cosine, I'm going to make it, sine of 90 minus 46, which is the sine of 44. And it's a true-false question. These are degrees. Okay, so remember, as the angle increases, the sine of the angle also increases. So this one is false. And that is because the sine of 46 is actually bigger than the sine of 44. So we had to use cofunctions on that one, so be careful and don't forget about your cofunction relationships. But the bigger the degree means that the sine of the angle is bigger. Okay, now let's do tangent and cotangent. Okay, so again, I have two different functions here. I'm going to try and use cofunctions so that I can rewrite these. So I'm going to change the cotangent into tangent of 90 minus 41. which gives me the tangent of 49. Okay, so now the question is again for tangent, we have a 41 degree here, angle here, and we have a 49 degree angle here. So we have to remember, does the tangent increase as theta increases, or does the tangent decrease as theta increases? So the way I like to remember the tangent ones, there's a little bit more math that goes into this, but remember that tangent at 0 degrees, that's 1 comma 0. The tangent here is 0 over 1, which is 0. And then what's the tangent up here? This is 90 degrees, 0 comma 1, which is undefined for tangent because it's y over r. So when you're starting at tangent at 0 and when you're moving this direction, if you're starting at 0, there's nowhere to go but up, you guys. So that means that as the angle increases, the tangent also increases. It's the same as the sine property. So the tangent increases, that means that as the angle increases, the tangent increases. So this angle is smaller than this one, so this is in fact pointing the correct direction. The bigger the angle, the bigger the tangent. Okay, so those are our first true-false questions. Those can get a little bit tricky. Make sure you continue practicing them and asking questions in class. But similar questions that you might be asked to do for problems that have to do with these properties is to order things from least to greatest. Okay, so we have all 4 of these functions here. Some of them are in cosine, some of them are in sine. The first thing I think to do is to change the cosines to sines. So I'm going to change this to sine of 90 minus 32, which is in fact sine of 58. I'm going to do the same thing over here. This is equivalent to sine of 78. And so now that I have them all in terms of the same function, it should be much easier to list them in order. So remember, as the angle increases, the sine increases. I'm going to actually make a little note of that. As the theta increases, the sine of theta also increases. So literally I just need to put these in order, least to greatest in terms of their angles. So if I had changed all of these to cosine, you guys, before I list the correct answer here, if I changed this to cosine and this to cosine, this rule would be different because this would be cosine and this would be a down arrow. But I would still get the same answer because they would still be in order from least to greatest. Okay, so just keep that in mind. If you were thinking of changing everything to cosine, you should still get the same answer, and I dare you to actually do that and then check your answer with mine. Okay, so the very first one, where is my smallest degree, which is the sine of 40. Next goes the sine of 50. Next goes the sine of 58, which you gotta write the original problem, which is cosine of 32. And the last one is the sine of 78, which is the cosine of 12. So those are the 4 things that I'm writing in order. So sine 40, sine 50. The next one was cosine 32, and I changed that into sine of 58. And the last one was cosine of 12, which I changed into sine of 78. Maybe in case you're curious what would happen if we changed everything to cosine, maybe I'll do that for letter B. I will change this, stays cosine, this is going to stay. I'll change this one and this one into cosine functions. And then we would still be able to list these in the correct answer, or correct order. So I'm going to change the sine of 70. I'm going to change it to cosine of 20 using the cofunction property. It's the cosine of 90 minus 70. And same thing over here. I'm going to change this to cosine of 48. Okay, tangent I can't really change because if I were to change it using reciprocals or using cofunctions, I would be using cotangent. Okay, so this one is a little bit funny, but I have a feeling that we can easily do this using the unit circle. 45 degrees, tangent is y over x. Oh, aren't the y and the x the same at 45 degrees? They're both radical 2 over 2. Oh, so tangent of 45 equals 1. That's important. Okay, maybe you have that memorized by now, maybe not. But another thing that I'm going to keep in mind here is as the theta increases, the cosine of theta decreases. So remember the x value gets smaller as you move from 0 to 90 degrees. So I need to list the cosine values in like decreasing order in order to list them from least to greatest. So actually my smallest value is the cosine of the biggest number. So I'm going to skip this tangent for a second. I will place that in just a minute, but my smallest value for cosine has the biggest angle. So my biggest angle is cosine of 48, and that was originally sine of 42, so that goes first. So I used that one. And now I'm working my way down. The next one is going to be cosine of 42. As the angle gets smaller, the x value gets bigger. And so I'm writing these in order of least to greatest, following directions. So cosine of 42, did that one. The next one is the cosine of 20, which happened to be sine of 70. So I'm going to write sine of 70. Did that one. The cosine of 2, you should be able to kind of visualize this. It's really small, but it has a really big x value, which is almost 1, because remember the radius is 1 for all of these. But with 2 degrees, that's like such a small angle that the x value is really, really close to just the radius, which is 1. It's a very small triangle there. So cosine of 2 goes next. And then the very last one is the tangent. That is my whole number 1, tangent of 45. One other thing to keep in mind is that remember how sine and cosine are all between 1 and -1. Same thing for cosine. So keep that in mind, that the tangent should be like on the end, depending on which way you're listing least to greatest or greatest to least. The tangent of 45, if it equals 1, it should be on the end, because cosine and sine have to be in between -1 and 1. Just keep some stuff like that in mind. This is how to order things back and forth. Okay, so that is the lesson for today. Just a little bit more review and some more further thinking in terms of what we've talked about in class already. So bring your questions to class. We'll work on some more problems tomorrow. Have a great night. Thanks for watching.